All right, the next component on the 4.03 quiz is still all about ions, but it's about this idea of a polyatomic ion. All right, so after this one, you should be able to distinguish. I keep spelling monatomic wrong. Monatomic ions from polyatomic ions. And as long as you're able to do that, that means you understand it. So, got another kind of diagram here. We've got our monatomic ions up top. All right, you can see they each only have one atom in there. All right, and then you got your polyatomic ions down below, and you can kind of just see looking at it. Oh, hey, these all have one atom in them. Polyatomic. That term poly, if you remember from math class, means many. All right, so there's many atoms in there. Just to kind of fill the table out so that you can see what's going on here. So nitride, all right, that's the nitrogen ion. It's got a 3- charge. It has one nitrogen. All right, and its chemical formula is N3-. All right, whereas nitrate, all right, its charge is -1. It has one nitrogen and 3 oxygen. So that's going to be NO3. The little subscript tells you that there's 3 oxygens, and that's going to be -1. Sulfate is right here. That has a -2 charge. I'm getting that from the little negative sign there. It has 1 sulfur, 4 oxygens. It's going to be SO4. And then 2-. Sulfite. I'll do that one in green since there's still sulfur in there. All right, that's got 1 sulfur and 3 oxygens. And its charge is also -2. And then ammonium has a +1 charge. 1 nitrogen and 4 hydrogens. So that's going to be NH4+. All right, so you're not already picking up on this distinct difference here between your monatomic and polyatomic ions. It really does come from those prefixes. So monatomic means ion made from one atom. Polyatomic is an ion made from many atoms. All right. Now, thinking back to our polyatomic ions, we had SO4, 2-, NO3-, NH4+. If you use your periodic table, you look up those things, sulfur, oxygen, nitrogen, hydrogen. What do all of those have in common? They are all nonmetal. All right, and that is true of polyatomic ions. They are always formed from nonmetals. All right, so when it comes to, forming, we're going to come to this in a couple more videos, but when it comes to forming an ionic bond, the polyatomic ion takes the place of the nonmetal component when it's needed. All right, but this is important to know. So, go ahead and give this activity a shot. But if you've got the difference between your polyatomic and monatomic ions, this shouldn't be too difficult. Just be careful. So, circle around any monatomic. I really need to go through and correct my spelling in here. So monatomic is going to have just one atom. I'm going to circle. So there's one atom. One atom. One. I know it's kind of hard to tell, but this is supposed to be aluminum, so that's one. Hydrogen's definitely one. Alright. And then you're going to box polyatomic ions. So I recognize sulfate from the last one. Nitrite was on there too, not that we labeled that one. And then let's see, I'm seeing a 3- here, and that has phosphorus and oxygen. And this is chlorine and oxygen. Why didn't I box or circle the ones that I didn't? Let's look at those carefully. What are they missing? These are all elements or compounds, not ions. All right, because to be an ion, you have to have a charge. So everything that I boxed, I know is an ion because it has that charge. Okay? So, summary for you guys. This is definitely a good spot to take some notes. So your monatomic ions are made from one atom. So mono means one. You should know the charge that the groups 1A through 7A make, what kind of ion they form. The B group, or you can even think of this as the transition metals, tend to make more than one. All right. Metals form positive ions, non-metals form negative ions. That's your important information to know for monatomic. Polyatomic, you need to know they make more than one kind. They are always from non-metals. So 99.9% of the time they have a negative charge. Ammonium, the NH4+, was the only polyatomic ion that you're probably ever going to interact with that has a positive charge. And then this is just some kind of extra note-taking stuff related to the reading that you want to make note of. All right, so they have similar electronegativity, and within the ion, the atoms are covalently bonded. So if you think about your SO4, there's covalent bonds connecting the S's and the 4's. It actually looks like that, but... Then I had one quick question that I wanted to go over, just because this isn't something that we specifically talked about in class. And I know you're going to see something like this on a quiz. And everything on here is an ion. We can see that. So let's break this word down. All right. So I see two components to this. We've got oxy. We've got anion. Anion, we know, means that it's going to have a negative charge. So from that alone, we can cross out ammonium. All right. The other component is we see oxy, and that probably sounds a lot like oxygen. So the only one that has oxygen in there is D. So that's one thing you don't always necessarily have to have things written into your notes word for word for you to figure out answers. Break those words apart. Those prefixes and suffixes and things like that come in really handy in science classes.